Welcome to Eureka Math. I'm Mr. Schenkel. I've got your Module 1, Topic D, Review 1 answers coming up. All right, number 1, find 3 consecutive integers such that their sum is 42. Well, first I'm going to define some variables and say what these integers are going to be. So the first one is going to be x. X is going to be the first consecutive integer. And then the next consecutive integer would be one bigger than that, so x plus 1. And then the third consecutive integer would be x plus 2. And I want their sum, which means I'm going to add all of those together. That gives me x plus 1 plus x plus 2, the first term, the second term, and the third term. And all of that is added together to equal 42. So when I combine like terms, that gives me 3x plus 3 equals 42. And then we're just isolating the variable. So subtract 3 from both sides. I get 3x equals 39. And then divide by 3, and we get x equals 13. So my first consecutive integer is 13. The second consecutive integer is 13 plus 1, which is 14. And the third consecutive integer is 13 plus 2, which would be 15. And when you add all those together, you get 42. All right, number 2, find 3 consecutive even integers such that their sum is 132. So x is going to be my first even integer. The next even number would be 2 bigger than my first, so that's going to be x plus 2. And then the third one would be 4 bigger, so x plus 4. And again, it's a sum, so I'm going to add all these together. That's, let's do it all at once this time. I have 3 x's, and 2 plus 4 is 6. So 3x plus 6 equals 132. Subtract 6. I get 3x equals 126. Divide by 3. X is, what is that, 42? 42. So what's the next even number? Well, that would be x plus 2, which is 42 plus 2, 44. And then x plus 4 would be 42 plus 4, 46. 42, 44, 46 equals 132. Number 3. 3 consecutive odd integers. Same thing. X is my first one. And if I think of my odd integers, if the first one's odd, then the next odd number is 2 bigger again. So x plus 2 is the second one, and x plus 4 is the third one. So we get 3x plus 6 is equal to 237. And isolate the variable. So 3x equals 237 minus 6 is 231. Divide by 3, and we get x equals 77. So my first odd number is 77. My second odd number is 77 plus 2. That's 79. And my third odd number would be 77 plus 4, and that is 81. So 77, 79, 81 are my 3 consecutive odd integers. Number 4. If 4 is subtracted from a number, okay, the number is x, take 4 away from that, and that result is multiplied by 9, the product, that answer to the multiplication problem, equals 171. All right, that's my equation, and then we just have to solve for x. So 9 times x is 9x. 9 times the negative 4 is a negative 36 equals 171. And isolate the variable. Add 36 to both sides. 9x equals 207, and 207 divided by 9. 207 divided by 9, x equals 23. All right, that's number 4. Number 5, a checking account is set up with an initial balance of $9,400 and $1,200 is removed from the account at the end of each month for rent. No other user transactions occur on the account. Write an inequality whose solutions are the months M in which the account balance is greater than 2,000. Well, I have 9,400 to begin with. Every month I'm subtracting 1,200, so 1,200 every month. And I want my balance to be greater than 2,000. So that's my inequality. And then it's just isolate the M. So subtract 9,400 from both sides. That gives me a negative 1,200 M is greater than 2,000 minus 9,400 is a negative 2,000 minus 9,400 is a negative 7,400. And then, look, I'm going to divide by a negative. And we have to remember that when we divide by a negative, we flip the inequality sign. So this happens. M is less than 7,400 divided by 1,200. And when we do that, we get 6, a positive 6.2, approximately 6.2. So the months would have to be less than 6 in order to stay above, have to be 6 or less in order to stay above 2,000. All right, number 6. The following sequence was generated by an initial value of a sub 0 and a recurrence relation. Whoa, part of this is missing. This should say a sub I. I don't know if I can get that in there. I plus 1 equals 2a. 2a sub I. That's weird how those were not there. 2a sub I plus 2. All right, and I'm going to actually rewrite that so that it's not so darn confusing. That should be on there. Well, I don't know where it went. A sub I plus 1 is equal to 2 times a sub I plus 2. All right, and we're going to say the initial value is a sub 0. So to get our first result, we're going to go a sub 0 plus 1 is 2 times a sub 0 plus 2. And if I further simplify, a sub 0 plus 1 would be a sub 1, which means my result after round 1 is 2 times a sub 0 plus 2. Okay, so there's our first round. And now each successive round, we're going to go back to our original recursive relationship, and we're going to use our last result, a sub 1 in this case, to further the pattern. So a sub I is really my last result, so that's a sub 1 plus 1 equals 2 times a sub I, which is our last result. Well, our last result is this. So that's 2 times 2a sub 0 plus 2, and then finally, don't forget this, add 2. And if we further simplify, a sub 1 plus 1 would be a sub 2, and that's equal to, well, 2 times 2 is 4a sub 0, 4a sub 0. Oh, I didn't do sub 0. And then 2 times 2 is 4, plus another 2 is 6. So there's our result after round 2. And then we just keep that going. A sub 2 plus 1 is equal to 2 times, well, whatever I finished with last time, which was 4a sub 0 plus 6. 4a sub 0 plus 6, and then don't forget the plus 2. Further simplify, a sub 2 plus 1 is a sub 3 And then 2 times 4 is 8a sub 0. And 2 times 6 is 12, plus another 2 is 14, so plus 14. So there's the third round. Fourth round, a sub 3 plus 1 is equal to 2 times my result from last round, which was 8a sub 0 plus 14. Don't forget to add the 2. Further simplify, a sub 3 plus 1 is a sub 4 is equal to 2 times 8 is 16 a sub 0 plus 2 times 14 is 28 plus another 2 is 30. So there's my result after round 4. And then we just need one more. A sub 4 plus, that's a 4, 4 plus 1. It's ugly. Is equal to 2 times whatever I ended with last time, which was 16a sub 0 plus 30. And then don't forget to add 2. And then we simplify it, and we get a sub 4 plus 1 is a sub 5 is equal to 16 times 2 is 32 a sub 0. And then 2 times 30 is 60 plus another 2 is 62. And that's the formula for round 5. There we go, number 6. Number 7, let's do that again. It was so much fun. Let's do it one more time. A sub 0 plus 1, a sub 0 plus 1 is equal to, well, it's a sub I, which we're going to call a sub 0, plus 3. That's it. A sub 0 plus 3. If I further simplify, a sub 1 is a sub 0 plus 3. And then we continue with our pattern using that recursive relationship. So my last result was a sub 1 plus 1 is equal to a sub I, which is my result from the last time. And that is a sub 0 plus 3 plus the other 3. So we can't forget the other 3. And if we simplify, this is a sub 2, the result after my second round, is equal to a sub 0 plus 6. And then we just keep going. A sub 2 plus 1 is equal to a sub 0 plus 6, my result from the last round, plus that 3. And further simplify, a sub 3 equals a sub 0 plus 9. And you probably see the pattern now. You could just kind of write it, but I'll continue. A sub 3 plus 1 is a sub 0 plus 9, my result from the last time, and add the 3 again. That gives us a sub 4 is equal to a sub 0 plus 12. That's our fourth round. And the fifth round, a sub 4 plus 1 is equal to the result from the last round, a sub 0 plus 12 plus the other 3. And when we get that further simplified, a sub 5, the result from my fifth round, is a sub 0 plus 15. And there we go. Oh, look at that. I went too far. I could keep going. That's number 7. Oh, one more thing. Describe in words what's happening. Well, you're just adding 3 to the last term. That's it. All right, 8. One more time. A sub I is going to be a sub 0 plus 1 is equal to 5 times a sub 0 plus 3. So further simplifying, that's a sub 1, the result after round 1, is equal to 5 times a sub 0 plus 3. And now I use that as my last one. A sub 1 plus 1 is equal to, well, it's 5 times my last result, which was 5a sub 0 plus 3, and then don't forget to add 3. So a sub 2 equals, well, instead of multiplying 5 times 5 and getting 25, I'm just going to list that as 5 squared times a sub 0 plus, well, 5 times 3 is 15, and 15 plus 3 is 18, so plus 18. Okay, so there's the result after round 2. Here we go, round 3. A sub 2 plus 1 equals 5 times the result from last round. Well, the result from last round was 5 squared a sub 0 plus 18, and don't forget to add the other 3. Simplifying a sub 3 is, well, 5 times 5 squared is 5 cubed a sub 0. 5 times 18 is 90, plus the other 3 is 93. So that's a plus 93. And then one more. A sub 3 plus 1 is equal to 5 times the result from the last one, which was 5 cubed a sub 0 plus 93. And don't forget to add the other 3. And then that gives us a sub 4 is equal to, well, 5 times 5 cubed would be 5 to the 4th power, a sub 0, plus, well, 5 times 93, let's get a calculator for that one, 5 times 93 equals 465, and then add the other 3, 468, so plus 468 is the formula for the 4th round. And there you have it. That is review number 1. I'll have review number 2 for you as well. See you next time.